When a Linux system is used by just one person in a simple lab, identity feels easy because you create a local account and everything stays inside that one machine. The moment you place Linux into an environment where many users exist and many machines need consistent access rules, identity becomes a shared system problem instead of a local preference. Organizations want one username to work across multiple systems, one set of group memberships to drive permissions, and one place to disable access when someone leaves. That goal is called identity integration, and it sits right in the middle of day-to-day usability and real security. In this episode, we build a beginner-friendly map of the concepts behind Linux identity integration, focusing on System Security Services daemon, SSSD, Winbind, and Realm basics, and how these pieces fit into the bigger access story you learned earlier. The aim is not to make you configure anything, but to help you understand what each component is responsible for so you can reason about common exam scenarios. Once you can explain the role of each layer, you can predict what breaks when identity integration is missing or miswired. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is to name the problem identity integration is trying to solve, because otherwise the tools sound like random jargon. On a single Linux system, local users and local groups live in local account databases, and the system can authenticate those users and apply permissions using only local information. In an organization, that model does not scale because every new user would need to be created on every machine, and every permission change would have to be repeated everywhere. Even worse, disabling a user would be inconsistent, leaving stray access on systems that were forgotten. Central identity systems exist so that authentication and group membership can be managed once and applied everywhere, which is both convenient and more secure. Linux identity integration is the set of mechanisms that let a Linux system ask a central identity source, who is this user and what groups are they in, and then treat that user as a first-class account locally. The key idea is that the Linux machine still enforces permissions locally, but it can consult a remote authority for identity facts. That separation between remote identity facts and local enforcement is the thread you should keep pulling as we discuss SSSD and Winbind. Before you place any tool names on the map, it helps to separate identity integration into 3 concept buckets that appear again and again in Linux questions. One bucket is identity lookup, meaning how the system learns that a username exists, what numeric identifiers it maps to, and what groups it belongs to. Another bucket is authentication, meaning how the system verifies credentials, which could be a password, a token, or an encrypted challenge exchange depending on the environment. The third bucket is policy and authorization, meaning how the system decides what the authenticated user is allowed to do, which includes both file system permissions and system-level privilege decisions. Identity integration mainly lives in the first 2 buckets, lookup and authentication, while authorization is enforced by Linux using group memberships and other policy layers. Beginners sometimes expect identity integration to magically grant permissions, but it only supplies identity and group information that Linux then uses to enforce its own rules. This is why group membership becomes such a big deal, because a central directory can define groups that map to access on Linux systems. Once you understand that the directory supplies the facts and Linux uses them, you can reason clearly about where the failure lives when access breaks. System Security Services daemon, SSSD, is one of the main components Linux uses to connect that remote identity world to local system behavior. At a high level, SSSD is a service that sits between Linux and an external identity provider, handling user lookups, authentication requests, and caching so the system can remain responsive. The caching part matters because a Linux machine cannot afford to stall every time it needs to translate a username into an identifier or check group membership. SSSD can store recently used identity information locally so that repeated lookups are fast and so that the system can continue functioning even if the identity provider is temporarily unreachable. That does not mean it ignores security, because authentication and authorization still have rules, but it does mean SSSD is designed to make integrated identity feel as smooth as local identity most of the time. Another major role of SSSD is standardization, because it provides a consistent way for the system to use different identity backends, rather than requiring every application to speak directory protocols directly. For exam-level thinking, treat SSSD as the identity broker and cache that helps Linux work with centralized identity sources. Winbind is another identity integration component you will hear about, and it is especially associated with environments where Windows-style directory and domain concepts are involved. Rather than thinking of Winbind as a competitor to SSSD, it is more useful to think of it as a different pathway for connecting Linux to a domain-based identity world. Winbind is commonly discussed with Samba-related integration and can help Linux systems understand domain users and groups in a way that aligns with Windows domain membership patterns. Beginners often get confused because they see both SSSD and Winbind in documentation and assume they must be used together, when in many practical designs you choose the approach that fits your environment and distribution conventions. The key exam-level point is that both exist to help Linux recognize and authenticate users that are not defined locally, but they may be deployed differently and have different typical integration stories. Another important idea is that Winbind is often described in terms of bridging Windows domain identities into Unix-style identifiers and group memberships, which is exactly the identity lookup bucket we discussed earlier. If you keep identity lookup as the core purpose, Winbind's role becomes much easier to place. Realm basics come into the story because a realm is a way of describing an identity domain, meaning a scope where a set of identity rules and authorities apply. In many enterprise environments, a realm is tied to a directory domain that defines users, groups, and authentication rules. When people say a Linux system is joined to a realm, they mean it is configured to trust that realm's identity provider, to recognize users from it, and to authenticate those users according to its policies. The reason the realm idea matters is that it sets expectations about naming and uniqueness. If two different identity systems both have a user named Alex, the realm concept helps distinguish which Alex is being referenced, and it helps prevent collisions. Realms also connect to how Linux maps remote identities to local identifiers, because those mappings must remain consistent or permissions become dangerous and confusing. For exam-level reasoning, you can think of a realm as a boundary that defines where identity comes from and how it is interpreted. When the system is not in the right realm or does not trust the realm properly, identity lookups and logins can fail even when credentials are correct. Active Directory, AD, is a common realm-style identity system in many organizations, and it shows up frequently in Linux identity integration discussions because Linux systems are often deployed alongside Windows systems. At the conceptual level, AD provides a centralized place to define users, groups, and policies, and it supports authentication methods that allow single sign-on in domain environments. A Linux system that integrates with AD is essentially agreeing to treat AD as an authority for identity facts and authentication decisions, which then allows domain users to log into Linux systems and be granted permissions based on their group memberships. This can feel intimidating to beginners because it sounds like Linux is becoming Windows, but that is not what is happening. Linux is still Linux, enforcing Linux permissions and running Linux services, but it is consulting AD for identity and authentication in the same way it might consult any directory service. The important exam-level point is that AD integration is a common use case for SSSD or Winbind approaches, and realm concepts are often the user-friendly wrapper around joining that identity domain. If you can explain the direction of trust and the role of the realm, you can answer many identity questions without memorizing configuration details. Caching is one of the most important concepts in SSSD-style integration because it explains both reliability benefits and certain confusing failure modes. When identity information is cached, the system can continue to resolve usernames and groups quickly, and it may even allow certain operations when the identity provider is temporarily unavailable. That improves usability, but it also creates a time dimension that beginners sometimes overlook. If group membership changes centrally, a Linux system might not reflect that change instantly if it is relying on cache data. and that can lead to the frustrating experience of permissions appearing wrong even after you fix them in the directory. The opposite can also happen, where a user who was removed might still be recognized for a short time, depending on how caching and refresh rules are configured. On the exam, you do not need to tune cache policies, but you do need to recognize caching as a reason for delayed effect. The healthy mindset is that integrated identity is a distributed system, and distributed systems often have propagation delays. When you remember that, you stop expecting instant global consistency and you start looking for timing and refresh behavior as part of the explanation. Another foundational concept is identity mapping, which is how a remote user becomes a local-looking user in a system that fundamentally relies on numeric identifiers. Linux permissions are based on numeric user and group identifiers, not on names, even if you usually interact with names. When a Linux system integrates with a directory, it must map remote identities to local numeric identifiers consistently so that file ownership and group permissions remain meaningful. If those mappings change unexpectedly, you can get dangerous situations where files appear to belong to the wrong user or where permissions behave unpredictably. This is why identity integration is not just about logging in, and it is about stable translation between identity worlds. SSSD and Winbind are involved in this translation story, and the realm concept helps define the namespace so collisions and ambiguity are reduced. For beginners, the exam-level insight is that identity integration is not purely about authentication success, and it is also about consistent identity representation over time. If you see scenarios about ownership or permissions changing unexpectedly after integration changes, identity mapping consistency is a strong conceptual explanation. Now connect this identity integration layer back to pluggable authentication modules, PAM, because this connection often shows up in how Linux actually makes authentication decisions. Many login methods and privilege transitions in Linux use PAM as the interface for authentication, and SSSD commonly integrates into that flow so remote authentication can be performed as part of the normal Linux authentication pipeline. This is why you can have a domain user login through a standard login method and have it feel like a normal Linux login, because the system is still using its usual authentication framework, but the framework is consulting an external identity provider through SSSD. The important exam-level point is not the implementation detail, and it is the layered relationship. PAM is the framework that many services use to authenticate, and SSSD can be one of the backends that provides identity and credential verification. Winbind can also participate in similar flows depending on how the system is integrated. If you remember that PAM is the common door and SSSD or Winbind can be the identity and authentication brains behind that door, you can explain why some logins fail while local logins still succeed. That is a classic sign that the integration backend is the failing layer, not the whole authentication framework. Troubleshooting identity integration, even at a conceptual level, becomes much easier when you separate lookup failures from authentication failures. A lookup failure means the system cannot even find the user, so it behaves as if the user does not exist, which can show up as login prompts rejecting the username immediately or permission checks treating the user as unknown. An authentication failure means the user is recognized, but the credentials cannot be verified, which might happen if the directory is unreachable, the time is wrong, or the trust relationship to the realm is broken. These failures can look similar to a beginner, but their meaning is different, and the layers involved are different. SSSD and Winbind often affect lookup behavior because they provide the directory-backed user and group data, while authentication depends on both that lookup and the ability to verify credentials with the identity authority. Realm membership problems often show up as both lookup and authentication issues because the system no longer has a valid trust relationship to the identity domain. For Linux Plus questions, the important skill is matching the symptom to the layer, because the answer is often about which component is responsible for which kind of decision. There is also a security trade-off dimension to identity integration that beginners should take seriously, because integration decisions shape both convenience and risk. Centralized identity makes it easier to manage access consistently, but it also means the directory becomes a high-value target because compromising it can grant broad access. Local accounts provide isolation but can lead to unmanaged sprawl and inconsistent offboarding, which is also a security risk. Integrated identity also introduces dependency on network reachability and time synchronization, because many domain authentication systems rely on correct time and on reaching domain controllers. That means NTP issues can turn into login failures, and DNS issues can turn into realm discovery failures, which is why basic services often appear in identity-related troubleshooting stories. The exam-level takeaway is that identity integration is a system of systems feature relying on networking, time, and trust relationships, not just on a username database. When those supporting systems are shaky, identity integration becomes brittle. Thinking about those dependencies is part of thinking like a Linux administrator, even as a beginner. Another important beginner misunderstanding is assuming identity integration automatically grants the same privileges on Linux that a user might have in another environment. Integration typically brings in the identity and group memberships, but Linux still enforces its own authorization rules. That means a domain user can log in successfully and still have limited permissions if they are not mapped into the right groups, or if the system's privilege policies do not grant them administrative rights. This is often a surprise because people equate domain membership with broad privilege, but Linux is usually more explicit, requiring membership in specific administrative groups or explicit policy to grant elevated actions. This is where your earlier understanding of Polkit fits, because a user might be recognized and authenticated, yet Polkit policy could still deny an administrative action. Integrated identity provides the raw material, like group memberships, that those policies can use, but it does not override the policies. For exam reasoning, remember that authentication success answers who you are, not what you can do. The what you can do still depends on local rules that use identity as input. A practical way to place SSSD, Winbind, and realm concepts on one map is to treat them as components that help Linux participate in a centralized identity world without giving up its local enforcement model. The realm concept describes the identity domain and the trust relationship the Linux system is joining. SSSD and Winbind are mechanisms that bring directory-backed users and groups into the Linux system and help authenticate them, often integrating into normal Linux authentication paths. Identity mapping ensures that remote identities translate into stable local numeric identifiers so permissions remain consistent and safe. Caching improves performance and resilience, but introduces timing considerations that can make changes appear delayed. All of this sits alongside, not instead of, Linux permissions, PAM authentication framework usage, and Polkit action authorization. If you can explain these relationships in plain language, you have the right conceptual grip for Linux plus questions that ask where identity integration fits. You do not need to be able to build an enterprise directory, but you do need to recognize how Linux connects to one and what kinds of problems arise when that connection is misaligned. By the end of this episode, the core idea is that Linux identity integration is a layered system that lets Linux use centralized identity facts and authentication while still enforcing local authorization rules. System Security Services Daemon, SSSD, acts as an identity broker and cache that helps Linux look up users and groups from external providers and authenticate them through normal system flows. Winbind is another integration pathway, often associated with Windows domain-style environments, helping Linux understand domain identities and group memberships in a compatible way. Realm basics describe the identity domain boundary and the trust relationship a Linux system establishes when it joins a centralized identity environment, such as Active Directory, AD. These components fit together with PAM, Polkit, and file system permissions as distinct layers that answer distinct questions about who a user is and what they are allowed to do. When you can place each piece correctly and recognize the difference between lookup failures and authentication failures, identity integration becomes understandable, troubleshootable, and exam-ready rather than intimidating.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.